This is a follow-up video to the previous video on how to handle inflation in engineering economy analysis. In the previous video, I argued that you can ignore inflation, but this is really only true when inflation is low, something lower than 4% usually. When inflation is high, you actually do need to account for it. I'm making this video in the end of 2021, and inflation is quite high right now, and so there is concerns about how to manage that in an engineering economy. So from the previous video, we had this investment of $1,200 that returned $300 a year for 5 years. And I went ahead and created a detailed cash flow for that. This is very similar to the detailed cash flow we've been looking at in this class. You can see revenue, expenses, depreciation, and that depreciation I assumed is a straight line depreciation. So we have $1,200 divided by the 5-year life. So it ends up to be $240 per year. Now you remember the depreciation is set in the year in which you bought the equipment. So in this case, we bought it in time period 0, and that then dictated the depreciation schedule for the next 5 years. And then that gave us income, taxes, net income, depreciation, and cash flow. And then the net present value is minus 68.2. So I'm highlighting here this depreciation value because this is actually one of the things that is impacted by inflation. What the ways we can handle it is we can actually inflate revenue and expenses. In this case, you can see they start to grow over time by that 5% level because that's what's happening. All dollar values are increasing. But the thing that doesn't happen is depreciation doesn't grow because we set it at the time in which we bought it in time period 0. So it's going to be fixed for this whole time period. And then so when you do those calculations, it includes the net present value is now minus 1086, when previously it was minus 628. The 1086 is the correct value. The minus 1086 is the correct value because this is what really would be happening. So that's one option for analyzing in a high inflationary environment, is actually to include inflation in all the cash values and then keep the things that are fixed or a schedule and keep those constant. And really the only thing that's going to be impacting is depreciation. That's the only thing that's going to be fixed and not changing. These red values are the values that I had in the previous video when I increased cash flow by 5% a year. And you can see these are a little bit different, and it's because the relative depreciation tax shields are falling over time because everything else is increasing. And so the cash flows are actually lower in this case because the depreciation tax shields are lower. So the other option is that we can include a 5% inflation by decreasing the real value of the depreciation tax shields. So if you look at this carefully, the revenue is flat. I'm ignoring inflation in revenue and expenses. But the depreciation values fall over time because they are not as much tax shields because they're fixed and they fall over time. So the way I do that is I take the depreciation and divide it by 1 plus the inflation rate to the number of years. In this case, it's 240 every year, so I just divided 240. But sometimes depreciation schedules change year to year, like in Macker's. But generally, you just take the depreciation and divide it by 1 plus the inflation rate. And you can see this gave me the same net present value as I had before, the minus 1086. So this is another option to do when you're using, when you're including analysis in a high inflationary environment. So in summary, in a low inflationary environment, less than 4%, you can ignore inflation because the errors in the forecast are more than the impact of inflation. In a high inflationary environment, though, you really do need to include it, and there's two options. You could inflate the values with the discount rate that includes inflation, or you can use real values and a real interest rate and decrease the value of depreciation tax shields using inflation rate. This is a lot. This is a lot of detail related to inflation, and inflation is actually quite complex. So I just wanted to introduce this to you, that it's different in a low and a high inflationary environment, and I hope that helps.